kind of see now is the parlance is moon, Mars, and beyond. And so that operative word beyond is a really important departure from that first statement, right? Because it sets up an opportunity where you can ask the salient question, all right, if the ultimate destination with human beings is beyond the orbit of Mars, right? What does that require? And so that's a great opportunity that then forces us to go ask questions and find out really quickly, yeah, chemical propulsion is just not going to do that, man. So anyway,
yeah. You have been in this area. You developed basically a new way of reworking the Alcubierre drive, right, with the toroidal field to reduce the power requirements. And I'll come back to that later. So there has been a ton of work. And then what you're working on now, kind of my feeling there is it is shrouded in technical language that a lot of people don't understand. And so they may miss it. And when I read through it at first, I was like, wow, that's interesting. And then I was like, oh my God, he is harnessing 0 point energy, right. And so again, this is, I mean, you talked about stories and culture. These are stories that would not have been believable 50 years ago, right?
Right. The vacuum, right? And we associate the word vacuum in that context with nothing, right? But what quantum mechanics tells us is that at the microscopic level, empty space isn't empty. It's full of fluctuating fields and forces, virtual particles, virtual ephemeral fermion, anti-fermion pairs, and photons. It's just a sea of activity. And so this sounds very contradictory to what we think of when we think of the word vacuum, right? Now, as peculiar as all this might sound to folks listening to this, there is a real classical observational consequence of this peculiar nature that I'm kind of articulating right now, and that is known as the Casimir forces, as you were saying, Tim. You heard me say that empty space isn't empty, it's full of fluctuating fields and forces, these little bits of energy, if you will. And you may remember from university, the parlance, matter is both a particle and a wave, right? So all these little bits of energy have wavelengths associated with them. So when we add up all the bits of energy on the outside, it's unrestricted, and we get a number, and that's technically our zero reference, right? But when we add up all the bits of energy that appear in between the two plates, any bit of energy with a wavelength wider than that gap, it doesn't contribute to the integral or the addition of all these bits of energy. So there's a deficiency of vacuum energy between the two plates that's coupled to that negative pressure, right? So there is a lack of vacuum energy between the two plates that results in a effective negative pressure between the two plates, and that results in a force that wants to cause these two plates to collapse, and that's called the Casimir force. Now, the problem with the textbook definition of the Casimir cavity, like we're talking about, is that once the plates have collapsed, you can't get any more energy out of the system. The watch spring has been unwound. You've got to pull them apart. You have to wind the watch spring again. And so this arrangement would only at best be a battery, right? And it would never be greater than 100% efficient. So you'd always have to charge it with something external, if you will. And so I think even if you look in the literature, you'll find some people have written papers over the years kind of exploring that as some kind of a battery alternative. So is there some way we could potentially modify the Casimir cavity concept that might then allow us to continuously extract energy, right? And so that comes to our innovation. And so what we've done is the original Casimir cavity concept, right, the two plates, right? We fabricate chips in a standard nanofabrication environment. We fabricate chips that have the cavity walls, right? But the cavity walls are affixed to the silicon substrate. We do not want them to move. So they are affixed to the silicon substrate. They are electrically connected on the silicon substrate, right? And then in the middle of the Casimir cavity gap, we put antennas. We have pillars that stick up through the gap. They don't touch the walls. They're in the middle. And they too are also affixed to the silicon substrate. So it's like skyscrapers with big poles down the middle of the street, if you will.
Well, and you actually have some of those chips on a plate that you showed me earlier. So
we've gotten really good at making them over the last 5 years. We make all kinds of little prototypes with many cavities on these chips. Getting close to 1 million or more if we can get that.